Okay, now this video is on radicals. Let a be a suitable real number and n be a positive integer greater than 1. And nth root of b is a real number whose nth power is b. For instance, 2 is a fourth root of 16 because when you raise 2 to the 4th power, you get 16. Negative 2 is also a fourth root of 16 because when you take negative 2 to the 4th power, you also get 16. So we have 2 is a fourth root of 16. Negative 2 is also a fourth root of 16. It is a fact that for any positive integer n greater than 1 and any real number b different than 0, b has exactly n distinct nth roots. On this basis, there will be 4 distinct fourth roots of 16, which are 2, negative 2, and another 2 which will be identified later. Principal nth roots. Let b be a real number and n be a positive integer greater than 1. So n could be 2 or 3 or 4, etc. When b is positive, the principal nth root of b is the positive real number whose nth power is b. When b is negative and n is odd, the principal nth root of b is the negative number whose nth power is b. The principal nth root of 0 is 0 itself. The principal nth root of b is denoted symbolically by the radical symbol with an index n of b. It is commonly pronounced the nth root of b. Some examples. Obtain all second roots of the given number. Which is the principal second root? Okay, so second roots, which we will call square roots of 64, are 8 and negative 8. Because 8 squared is 64, also negative 8 squared is 64. Which is the principal second root? Which is the principal square root of 64? It has to be 8. Obtain all second roots of 1. Well, there are 2 of them. One of them is 1, the other one is negative 1. The principal one will have to be 1. I need the second roots or square roots of 625. There are 2 of them. One of them is 25. The other one is negative 25. Notice that 25 squared is 625. Also, negative 25 squared is 625. Which of them is the principal square root? The principal square root, the principal second root of 625 is the positive one, 25. So here are our answers. So second roots, 8 comma negative 8. Principal second root, which I'm going to say principal square root, is 8. For 1, the square roots of 1 are 1 and negative 1. The principal square root is 1. And finally, Obtain all square roots of 625. Well, one of them is 25. The other one is negative 25. The principal one is, the principal square root of 625 is 25. It's the positive one. Obtain the principal third root of the given number. So now we're thinking, what real number do you raise to the third power to get 64? 4 times 4 is 16. 16 times 4 is 64. So the principal third root of 64 is 4. The principal third root of 1 is 1. What is the principal third root of negative 27? Well, it has to be negative 3 because negative 3 to the third power is negative 27. Let me note that when you talk about the principal third root, you are talking about the cubic root, the principal cubic root. The third root is also known as cubic root. Obtain the indicated principal nth roots. So fourth root of 16, what is the positive number that you raise to the fourth to get 16? 2. The principal fifth root of 32 is going to be positive. Question is, what do you raise to the fifth power to get 32? Answer is 2. What about the principal fifth root of negative 32? You're thinking of a negative number whose fifth power is negative 32. That's right, negative 2. What about the principal square root of negative 9? When you talk about principal roots, when you talk about this number, b would have to be positive because we have an even number. So at this point, you're not going to get a negative number, you're not going to get a positive number. So the principal square root of negative 9 is actually undefined. No real number, when you raise it to the second power, gives you negative 9. So you could say it's undefined or it does not exist. That's not to say that there is no second root of negative 9 or square root of negative 9. That just means that it is not a real number. Some terminology. When you write the nth root of b, n is called the index, b is called the radicand, and that, of course, is the radical symbol. The principal second root of b is commonly called the square root of b. And you write it without the index. The third root of b is commonly called the cubic root of b. We use the term radical to refer to any principal root. Last examples on principal roots. So let's try this one. Obtain the indicated radical. Square root of 9 is 3. Cubic root of 64 is 4. Cubic root, fourth root of 81. What do you raise to the fourth to get 81? It happens to be 3, positive 3. When you're looking for square root of negative 16, it's not a real number. Not a real number. You could say it's undefined in the real numbers as well. Now let's talk about how to do operations with a radical. So let's begin with multiplication and division. So 2 rules. When you have, so let a and b be suitable real numbers and b greater than 1 be an integer. So it could be 2 or 3 or 4, etc. First rule, the nth root of a times b is the same as the nth root of a multiplied by the nth root of b. The nth root of a over b is the same as nth root of a over nth root of b. So using these rules, I want to simplify the following radical expression. So Here I have the square root of 49x to the 6th power. So let's see. According to the first rule in this list, the square root of 49x6 can be viewed as the square root of 49 multiplied by the square root of x to the 6. So now each of these square roots, the square root of 49 and the square root of x to the 6, can be simplified. The square root of 49 has to be 7 because 7 squared is 49. Now you have to ask the question, what is the square root of x to the 6? What do you square to get x to the 6? It has to be x cubed, because remember that x cubed is to the 2nd power. So let me write because x cubed to the 2nd power turns out to be x to the 6th. So it's x to the power 3 times 2, but that's simply x to the 6th. So in conclusion, the square root of x to the 6th is just x cubed. Next example. I want the cubic root of a to the 3rd, b to the 12th. So I split that up into the cubic root of a to the 3rd multiplied by the cubic root of b to the 12th. So now individually, I want the cubic root of a cubed. What do you raise to the 3rd power to get a cubed? That happens to be a. So the cubic root of a cubed is simply a. Next question. What do you raise to the 3rd power to get this answer, b to the 12th? So let me put it in here. What do you raise to the 3rd power to get b to the 12th? Well, it has to have a b in it, and it has to have a power in it as well. The question is, what is the power? Well, that power times 3 better be 12. So that power has to be 4. So let's answer the question. What is the cubic root of b to the 12th power? Answer, b to the 4. Because it is b to the 4 that you raise to the 3rd power to get b to the 12th. Okay, number 3. Notice that here I have the cubic root of a fraction, cubic root of 512 over 3375. When I have an nth root of a fraction, I break it into a quotient of fractions. So here, what I'm going to get, this is the same as the cubic root of 512, the cubic root of 512 over the cubic root of 3375. Now you just have to individually do these two calculations. What is the cubic root of 512? What is the cubic root of 3375? Well, if you think about what do you raise to the 3rd to get 512, so raise something to the 3rd and see if you get 512. Let me try something like 8. 8 to the power 3, 8 to the power 3, 512. Oh, that was lucky. It's 8. The numerator is 8. That was lucky of me. And now let's think about what would you raise to the 3rd power to get 3,375. Let's try something like 15 to the 3rd power. 15 to the 3rd power. Very lucky. It's 15. Of course, I know the answers. So there's your result. one more. So we want the fourth root of 81 over 625x8. So let me apply my rule. Nth root of a over b is nth root of a over nth root of b. So here I have a fourth root of 81 over fourth root of 625 x to the 8th. Okay, so let's see the results. On the numerator, you can see that the fourth root of 81 is simply 3, because 3 to the fourth is 81. For the denominator, you should notice that it's the fourth root of a product, 625 times x to the 8th. So we should split that up, that denominator, we should split it up by using our first rule. So I would say the fourth root of is 625, and then multiply that by the fourth root of x to the 8th. So, do you see that? I have the fourth root of 625 x to the 8th. So I get the fourth root of 625 and the fourth root of x to the 8th. Now, figure out what each of those individual roots are. So let's do it this way. I would like to know the fourth root of 625. What do you raise to the fourth to get 625? If you think long enough, you find out it has to be 5. And then the fourth root of x to the 8th. So you're asking, what do you raise to the 4th power to get x to the 8th? And you have to think about x squared, because x squared to the 4th power, when you multiply 2 and 4, you get 8. So the fourth root of x to the 8th is x squared. So notice that a good way of finding out what the exponent should be is take this 8 divided by that 4. 8 by 4 is 2. So I get x to the 2nd power. Okay, so good enough for now. That's all for now.